In this question, vapor pressure of a chloroform and the dichloromethane is given as 200 mm and 415 mm of Hg. We have to calculate the vapor pressure of the solution prepared by mixing 25.5 gram of chloroform and 40 gram of dichloromethane. This is the first part of the question. In the second part, we need to find the mole fraction of each the component in vapor phase. So what we do, first we write the given values. Vapor pressure of a pure component of a chloroform is equal to 200 mm. Similarly, vapor pressure of a pure component of dichloromethane is given as 415 mm. This is known. Similarly, masses are also given. Mass of the CHCl3 is equal to 25.5 gram and the mass of CH2Cl2 is equal to 40 gram. In the first part of the question, we need to find the total pressure Pt. It's equal to P CHCl3 plus P CH2Cl2 because these two components are mixed together. So if we use the Rolle's law, we know that pressure of a component is equal to the vapor pressure of a component in the pure form into the mole fraction of the component. So here if you see, according to the question, we know the value of the P naught, but we don't know the value of the mole fraction. So better first we find the value of the mole fraction and then we solve this PCHCl3 value. So what we do, we use the relation XCHCl3 is equal to the mole of CHCl3 divided by mole of CHCl3 plus mole of CH2Cl2. This is the formula of a mole fraction. Now, first we find the mole of CHCl3. So we can say that NCH2Cl3 is equal to mass of CHCl3 by molar mass. Mass is given as 25.5. So we can write it as 25.5 and molar mass we get around 119.5. So from this information, mole of CHCl3 is equal to 0.213. Similarly, we need to find the mole of CH2Cl2. So it's given as mass is how much? 40 gram and its molar mass is 85. So it's equal to 0.47. Now we know the mole of each of the component. So if you substitute that mole in this relation, so we say that XCHCl3 is equal to 0.213 divided by 0.213 plus 0.47. It's equal to 0.213 divided by 0.683. 0.311. So we got the mole fraction of CHCl3. If we have to find the mole fraction of CH2Cl2, it's equal to 1 minus mole fraction of CHCl3. So 1 minus 0.311. XCH2Cl2 is equal to 0.689. Now we got the mole fraction of both the components. Now what we do, we can substitute the values in the given formula. So we can say that PCHCl3 is equal to 200 into the mole fraction is 0.311. It's equal to 62.2 mm. So we got the pressure of CHCl3. Similarly, if we have to find the pressure of CH2Cl2, it's equal to 415 into 0.689 because the mole fraction of it is 0.689, 286 mm. Now we have the vapor pressure of each of the component and we have to find the total pressure. So we can substitute the value in this formula. So we can say that Pt is equal to 62.2 plus 286. It's equal to 348.2 mm. So this is the answer of the first part of the question. Now we have to find in the second part of the question mole fraction of each of the component in vapor phase. So for this we can use the Dalton's law formula. P is equal to Pt into Y. So Y for CHCl3 is equal to P of CHCl3 by P total. So here we know that PCHCl3 is 62.2 and the total pressure is 348.2. So it's equal to 0.18. Now we got the mole fraction of CHCl3 in the vapor phase. So if we have to find the mole fraction for CH2Cl2, we write 1 minus mole fraction of CHCl3. So it's equal to 1 minus 0.18 and 0.82. So this is the answer of this question.